So we'll talk today about cybersecurity, the importance of a robust cybersecurity for achieving manufacturing resilience. Let's give a warm welcome to our expert from the Governance, Risk and Security team at GE Vernova, Susan Webster. She comes ready to discuss secure development lifecycle, secure cloud infrastructure, and more. In one word, defense. Susan, over to you.
Hi everyone, thank you for coming and joining us today. So designing security in isn't just about designing security into our products. It involves designing it into our organisation and our own infrastructure, as well as the product development lifecycle. So within GE Vernova, we are part of the electrification software business which supports the manufacturing team as well as a few others. We have over 50 experienced security experts working in the cybersecurity organisation. We're organised into 4 main pillars. The first being planning to ensure that secure architecture standards and designs are available. Operations to ensure that those systems, once they're designed and introduced, that they are operated in a secure way, that vulnerabilities are managed, that incidents are responded to promptly and our systems are monitored, and that the data that we have and that we hold is protected. We have a product security team who oversee the secure development lifecycle, ensuring the teams are equipped with the latest information and tools to make sure the products we produce are secure. Responding to any product-related incidents with our customers, dealing with defects, so those are not just quality defects but product vulnerabilities, and performing pen testing of our products and our environments. And within our engineering teams, we ensure that we have secure engineering environments for the development and deployment of our products, and where we host our customers' environments, that those are also operated in a secure way. Overseeing this, we also have the risk and compliance team, which is what I'm part of, and we look at policies, enforcement, rollout, risk management, and audits and certifications. So why is cybersecurity important? We need to make sure that this infrastructure that we operate on for both our on-prem and our cloud offerings are secure, and that the products we develop for your use are secure as well. There are a number of cybersecurity challenges facing all organisations. These range from workforce and people-based challenges, including identifying the activities of malicious insiders and dealing with human error. We've got regulatory pressures which impose expectations and obligations across the business life cycles and pass things back to ourselves as part of your supply chain. We've got the ongoing interconnectivity of systems and environments. Now, very rarely are things air-gapped, and multiple vendors are often involved with connecting to similar systems. More tools means that we have more patching and upgrade expectations, and more data is captured, maintained, and needed to be protected. On the negative side, we have targeted malware for the different types of industries and environments. Ransomware and crypto mining has become more prevalent, and in particular branded bugs, which are used to exploit known vulnerabilities. In short, there's a lot of challenges facing all organisations, but in particular in manufacturing organisations. I work for a part of the business that oversees both manufacturing and other business sectors, and sitting in abstract, we would not have previously thought that manufacturing was the subject to the largest number of cyber attacks. Generally, people assume that finance and where money is becomes the biggest targets, but no, we were wrong. In 2023, it turns out that manufacturing organisations were subject to the biggest share of cyber attacks. So how do we ensure that our products are produced secure in a secure way and are secure when they will be operated in your environments? Well, the traditional software development lifecycle of requirements, design, development, testing and deployment is supplemented and integrated into this life cycle are key cyber and security requirements. So you've got the requirements phase where we would have requirements for third-party products, for product capability, for compatibility with other tools and systems. And we also ensure that our teams are trained to make sure that they follow the life cycle that we have designed. When we design enhancements to our products or new products, we make sure that risk assessments are performed to understand where their weaknesses could be and what security features are required. When we start implementing those designs, threat modelling is engaged and design reviews. We also have secure development checklists for our engineers so that they do not introduce common vulnerabilities or threats based on bad practice. When we come to test our product, we make sure that security scanning takes place, as well as SaaS, DAST and open source scanning. And when we deploy in the cloud and manage the system on your behalf, we perform ongoing vulnerability scanning. It's a continuous cycle, which means we learn lessons from previous iterations and constantly improve what we do. So going into a bit more detail on secure verification and the role of pen testing, we have a cyber research lab, also known as the Red Team. This is an internal team to electrification software, and it is staffed by cybersecurity researchers with a diverse set of experiences in protecting both products and public-private entities and infrastructures. By being an inside team, it means they have insider access to people and processes and knowledge. They use leading-edge testing and tools and methods, plus in-depth testing of authentication and authorization, managing the critical data flows and critical mechanisms within our products. Performing pen testing is required for product release. This is on both a quarterly and annual basis, and out-of-band testing is conducted on subcomponents where they undergo major changes. For all the benefits that an internal Red Team bring, we also engage an external pen testing party for annual testing of our hosted infrastructure to make sure that we aren't too inside when we are doing this hosting and testing efforts. More information is available on our website and links are shown here. So fixing any issue, whether that is a quality issue or a vulnerability, has a different cost depending on where it is identified. A weakness identified during the requirements or design stage is round about 1,000 times cheaper to fix than something identified in production. And by cheaper, we mean engineering effort, testing effort, communications effort. There's a lot more cost involved with identifying something identified in production, which means that we have shifted left in our life cycle to make sure that more testing and validation takes place prior to release into production, therefore reducing the number of issues identified during production. We have gained and retained a number of industry recognised certifications. These have been maintained over the last 7 or 8 years. We have ISO 9001, which is our quality management certification. We have 27001, which is our information security management standard. We also have extensions to this standard. So we have 27017, which is about protecting information in the cloud. 27701, which is our privacy information management standard, and the extension to that of 27018 for managing privacy of information within the cloud. These certificates are also available from our website, and we undergo annual surveillance audits and 3 yearly recertification audits with our external assessor. So what is defence in depth? Well, the principles for security by design means we aim to deny attackers the means to compromise our products and environments by minimising the number of targets and by not exposing vulnerable components. So breaking this down, we want to deny attackers the means to compromise our products or products when you deploy them by having a simplified design, holding all actors who use the system accountable, simplifying timing and synchronization of messaging, making it difficult to enter vulnerable states. We also design in controllability and secure failure where things go unexpectedly. We minimize the number of targets by employing the principle of least privilege and separating privileges and roles and having separate domains. We don't expose vulnerable components by separating program and data, separating trusted and untrusted data and sources, minimizing the number of entry and exit points, and assuming that data is not trustworthy and only using trusted interfaces. Defense in depth starts with protecting the data at the heart of this application and using endpoint security controls, encryption of the data, identity and access management and authentication steps. Within the application, we have password management, employee vulnerability management, and the secure development lifecycle already outlined. Ensure that communication between components is done securely and employ identity and access management controls. The host that the application resides on is subject to vulnerability and patch management practices, internal intrusion protection systems, antivirus scanning, firewalls. It's hardened to industry best practice. Access controls are employed to ensure that only those who need access to the host are able to, and containerization practices are employed where possible. On the OT network, we segregate into security zones, have segmentation in place, have network IDSs and internal firewalls. For the edge and boundary defenses, we continued with vulnerability management, access and password control, device identity and inventories and certificate management, and the use of firewalls, and again, IDS and IPSs, using VPNs and DMZs to control how things are accessed. Where equipment is stored in a physical sense rather than in the cloud, we ensure that that physical equipment is also protected using key cards to gain entry, having a locked server storage, blocking ports, employing gates and guards for people to get into the room. And surrounding all this, we have comprehensive policies and procedures, as noted previously, governed by our certifications, and make sure our staff who have any contact with this series of activities are aware of what the expectations are. In addition, we have instant reporting processes, compliance reporting steps, employee business continuity and disaster recovery plans and processes as well. So where we host your systems in our cloud infrastructure, we have 24/7 monitoring and instant response using a follow the sun model to ensure that anything is identified promptly that needs to be investigated. We have centralized logging and telemetry, again, so that we can monitor effectively. It is also covered by our 27001 certification. We ensure that workloads and accounts are deployed securely using only secure configurations, standard cyber tools, continuous internal and external monitoring of traffic to ensure that nothing happens that's unexpected. We have a number of resources available to you as customers. We have our Security Trust Centre available on our website that has a number of white papers and other pieces of information that you will find useful to help evaluate our practices and our approach. And changing the subject slightly, we'll talk a little bit about the NIS2 initiative. So this is the second incarnation of an EU regulation to improve cybersecurity capabilities across the EU. It sets expectations on how EU nations will approach incidents and information sharing, as well as expectations applicable to 18 different business sectors. It applies to organisations which operate or sell their products within the EU. How can we at GE Vernova support NIS2 compliance? Well, first of all, we support your supply chain risk assessment programme by sharing information on our cybersecurity programmes, as I've already outlined. By holding these sorts of sessions, we have information slots in conferences and information is shared via our Trust Centre. and also by gaining and retaining industry recognised certifications so that you have an assurance that what we are doing meets those best practices. Secondly, our cloud infrastructure is subject to the 24/7 monitoring and incident response controls, meaning that should the unexpected happen, we can support your organisation's incident reporting requirements to your national CERT organisations. So NIS 2 is recently been published, and I realise that many of your organisations will be subject to this. And if you do have other requirements to support your NIS 2 reporting, then you can contact us through the usual channels. Cybersecurity is a partnership in a number of different ways. We have common goals across our cyber and engineering teams. We ensure that best practices for secure deployment and development are in place. We have tight collaboration with our customers' IT teams to ensure that your cybersecurity priorities are met, and we produce and maintain product secure deployment guides which aid you in deploying our products securely.